So, is time even real? It sounds like one of those questions you'd ask late at night staring at the ceiling, right? But it's actually one of the biggest, most mind-bending problems in all of modern physics. So, yeah, let's dive right in.
I'm sure you've heard this one before, or something like it. Time is what keeps everything from happening at once. It's clever, for sure. Kind of makes sense on the surface, and it lets us just, get on with our lives. But when you really try to use it as a scientific definition, it doesn't really help us much at all.
But what if that feeling we all have, that constant river of time, always flowing forward? What if that's not fundamental? What if it's not a basic piece of the universe's puzzle? What if it's something else completely?
All right, so to really get to the bottom of this mystery, we have to start with what seems like a simple question. What is time anyway? And you'd be surprised, but this is where things start to get really, really tricky right off the bat. I mean, try it yourself. Try to define time without using the word time or concepts that depend on it. It's super hard. If you look it up, say on Wikipedia, you just end up running around in circles. It's this weird logical loop that doesn't actually tell you anything.
And this right here, this is the core of the problem. We say, okay, time is what a clock measures. Fair enough. But then what's a clock? Oh, it's a thing that measures time. See? It's a completely circular definition. It tells us absolutely nothing new. To get a real answer, we've got to break out of this loop.
Thankfully, a guy named Albert Einstein came along and basically handed us a way out. His theories of relativity, well, they didn't just change things, they completely blew up our entire understanding of the universe. And right at the heart of that was a totally new way of looking at time.
So here was Einstein's big, brilliant idea. What if time is just another dimension? Like length, width, and height. He said that space and time aren't these two separate things we thought they were. Nope, they're actually woven together into this single four-dimensional fabric. He called it space-time.
Okay, but time is obviously a weird kind of dimension, right? I mean, think about it. You can decide to stand still in space. You can just stop walking. But have you ever tried standing still in time? You can't do it. We are all, every single one of us, constantly hurtling into the future.
So, if time is a dimension, that brings up a pretty strange question. We can move left or right, up or down in space. So, how do you change how you move through time? Well, believe it or not, you do it every single time you get up and start walking.
Okay, here's how it works. Imagine you have a certain fixed amount of motion energy to spend in space-time. When you're just standing still, 100% of that energy is being used to travel through time. But the moment you start walking, you have to borrow some of that time travel energy and use it for space travel instead. You're trading one for the other.
Now, obviously, you can't just trade all of your time motion for space motion. There's a hard limit. And that limit is the ultimate speed limit of the universe, the speed of light. The closer you get to that speed, the more and more of your motion gets diverted from the time dimension into the space dimensions.
And this all leads to a conclusion that is just mind-blowing. The faster you move through space, the slower you move through time. And listen, this isn't just some sci-fi theory. This is called time dilation. And we have measured it. We've confirmed it with insane precision over and over again. It's real.
All right, so case closed, right? Time is just the fourth dimension. Easy. Well, not so fast. Because as amazing and successful as Einstein's theory is, physicists are pretty sure it's not the whole story. And this, my friends, is where things get really weird. You see, general relativity, for all its power, has some big problems. It breaks down in places like the center of a black hole. And famously, it just does not get along with our other bedrock theory of physics, quantum mechanics. They're like two superstar actors who refuse to be in the same movie. So most physicists think general relativity is just a really good approximation of something deeper, a theory of quantum gravity. And this is the epic battle at the heart of modern physics. In Einstein's world, time is dynamic. It's flexible. It can be warped by gravity. But in the quantum world, time is just there. It's like a rigid universal clock just ticking away in the background, the same for everyone. These two views are completely, totally incompatible. They can't both be the final answer. This massive conflict has pushed some physicists to a really radical idea. What if the reason these two theories won't fit together is that they're both getting something wrong? What if the key is to just get rid of time? Not our experience of it, but time as a fundamental piece of reality. And this has led to some ideas that will seriously bend your brain. Okay, idea number one. Picture the very, very beginning of the universe.
What if there was no time dimension yet, just space? In this view, the Big Bang wasn't an explosion that happened at a certain time. The Big Bang was the event where time itself was born from pure space.
Here's another one. What if, at the most fundamental level, the universe isn't made of space or time, but just a giant network of connections between things? And what we call time is just our brain making sense of a particular path through this incredibly complex web. It's not a real thing, just a useful description.
And then there's maybe the wildest idea of all, from a physicist named Julian Barber. He says, just get rid of time completely. It's not real. The only things that are real are individual, static moments, like photographs of the universe. He calls them nows. And our feeling that time is flowing, he says that's just an illusion, created by how our brains link these frozen snapshots together in a logical order.
Okay, wow. So, after all of that, timeless universes, cosmic networks, a universe of nows, where does that leave us? I mean, is time real or not? Let's try to pull all these threads together.
We're right back where we started, asking that big question, is time real? But now, after everything we've looked at, you can probably see why the answer isn't a simple yes or no. It's a little more complicated than that.
Here's a great way to think about it. Look at a chair. Is a chair real? Of course it is. You can sit on it, right? But if you zoom all the way in, there's no such thing as a chair particle. A chair is just a particular arrangement of atoms. It's what we call an emergent property. The chairness emerges from the atoms. So, what if time is like a chair?
And that really brings us to the big takeaway here. For you and me, in our everyday lives, time is absolutely real. Our entire existence is built on it. But it might not be fundamental. It might not be part of the universe's basic programming. Instead, it could be an emergent feature, something that comes into being from a much deeper, stranger, and possibly timeless reality that we're just starting to get a glimpse of.
And that leaves us with a thought that even Einstein couldn't shake. That this feeling we have of past, present, and future all flowing in a nice, neat line might just be an illusion. A stubbornly persistent illusion, as he put it, that masks a reality that is far, far stranger than we can possibly imagine.